The single core objective of the entire HR selection process is to accurately predict a candidate's future job performance. Despite the high financial stakes of getting a hire right, standard hiring practices often rely on unstructured intuition and subjective gut feelings about an applicant. Relying on those instincts introduces a high degree of unpredictable variance into an organization's talent pool. One manager's good feeling is another's red flag, making the resulting hire little more than a coin toss. Building an optimal selection system requires abandoning subjective guesswork and treating hiring as a strict predictive science, anchored by psychometric data. Any selection tool must meet two foundational psychometric requirements to be considered scientifically and legally sound. The first is reliability, which is the consistency of scores obtained by the same person when they are retested. We check for reliability over time using methods like test-retest estimates, or by measuring internal consistency using statistical tools like the Cronbach alpha. If a candidate scores differently from one day to the next, the test is unstable. The second requirement is validity. This addresses accuracy. It asks if the test actually measures what it purports to measure. There are three primary types. First is criterion validity, which tests whether the predictor, the test score, directly correlates to the criterion or actual job performance. Next is content validity. A selection procedure has content validity if it representatively samples actual parts of the job, like a filing test for a clerk or a cash register simulation for a grocery checker. Finally, construct validity evaluates how well a tool measures underlying psychological traits, like mechanical ability or leadership, which are inferred from job descriptions. While an assessment tool can be perfectly reliable, returning the same score every time, it is useless for predicting performance if it lacks validity. Proving an assessment tool has validity before using it on candidates requires a specific operational sequence. Industrial psychologists follow this 5-step validation process to build a defensible test battery. In step 1, we analyze the job to specify required human traits. In step 2, we choose tests for those predictors based on research to assemble a cohesive battery. Step 3 is administering the test. We can use concurrent validation by testing current employees, or predictive validation by testing candidates and measuring their performance later. Step 4 relates test scores to performance criteria. This requires a correlation analysis between the actual scores and job performance metrics to develop an expectancy chart. Step 5 is cross-validation. We repeat the entire testing process with a different sample of employees to ensure the statistical model remains consistent. Executing this exact sequence provides a legal defense against claims of discriminatory hiring by grounding the assessment in proven operational math. This chart shows the mathematical outcome of a correlation analysis. It plots test scores on the left against the percentage of high performers found in each bracket. In the highest tier, candidates scoring between 57 and 64 have a 97% chance of being rated a high performer. In contrast, the lowest bracket has only a 29% chance of success. The test accurately separates the talent pool. While validated tests of mental and physical aptitude provide strong data, other common methods fail the validity test. Consider graphology, or handwriting analysis. Analysts study an applicant's signature and handwriting to attempt to discover their psychological makeup. Graphology tries to establish construct validity by claiming certain physical strokes indicate personality traits, but it fails empirical correlation analysis. It does not predict job performance. Highly valid alternatives include work samples or management assessment centers, where candidates perform realistic tasks like leading group discussions or solving management games. Tools that measure performance on actual job tasks possess the highest degree of content validity. They are difficult to fake and consistently outperform projective personality tests in predicting success. We must now apply these psychometric standards to the employment interview. The most common format is the unstructured or non-directive interview, where questions are not prearranged. This leads to massive inconsistencies in candidate evaluation. Unstructured interviews frequently fail the validity test because they are corrupted by specific cognitive biases. First impression bias leads interviewers to jump to conclusions within the first few minutes, which overrides any data presented later in the conversation. Candidate order error occurs when an average candidate is judged much more harshly because they were interviewed immediately after a stellar candidate. Pressure to hire causes managers facing urgent quotas to subconsciously lower their standards, approving candidates they would otherwise reject. Because of these biases, unstructured interviews measure the interviewer's psychological flaws more than the candidate's actual ability. The solution is the structured or directive interview. Structured interviews follow a set sequence of standardized questions to increase consistency across all candidates and enhance job relatedness. They utilize situational questions, which focus on how a candidate would hypothetically handle a job-specific scenario. They also use behavioral questions, based on the principle that past behavior in specific situations is the most reliable predictor of future behavior. The success of this entire process depends on replacing human intuition with validated measurement. By combining structured behavioral interviews, empirical work samples, and a rigorously validated test battery, organizations replace administrative guesswork with a system that minimizes turnover and ensures high-performing hires.